Okay, let's take a look at another type of application problem you see in this chapter. Let's take a look at the investment problem here, involving putting money in some interest-bearing account and see what kind of interest we can make from that. Right? So let's take a look at those concepts. Let's look at investment problems here. So investment problems. All right. So this involves a simple interest formula. So let's recall what that is from the previous homework or chapter here. So let's take a look at the simple interest formula. Simple interest formula. Right. So the simple interest formula is just going to be the interest I equal to the principal P times the rate, interest rate that is, R, times the time of the investment, T. So again, I stands for interest, or the interest you're going to get in an account. So let's call it interest income or interest earned. Alright, P is the principal. R is the interest rate. And T is the time of investment. Time of investment. Alright? Now, for the purposes of the problems in this section, we're just going to invest the principal into a 1-year account. So, therefore, T is equal to 1 for the homework problems in this section. Alright? So let's let T equal to 1 for 1 year. Alright? So if that is the case, then this formula I equal to PRT is simply going to simplify to PR times 1, right? Which is, since T is 1, then that's just going to be P times R. Alright? So therefore, the interest income in an account is simply going to be the principal times the interest rate. Again, time will be for 1 year. Alright? So let's use this formula to solve word problems in this section. Let's put this in a table format as we've done in the past, perhaps, right? But let's take a look at the table setup, if you will, for this type of problem. Alright? So let me go ahead and put this formula on the table and show you how to set that up as per your textbook here. Let me go ahead and clear out the screen. All right, let's take a look at this problem here. A total of $8,000 is deposited into 2 simple interest accounts. All right, one account earns 5% annual simple interest, while the other earns 6%. All right. How much should be invested in each account so that the total annual interest earned is $450? So I'm going to make $450. I want to make $450 per year on this $8,000 into these 2 accounts. So how should I invest it to achieve this result? All right. Let me also wonder, well, why not put everything into the 6% since it's higher? Well, the reality of it is that when you're investing here, the higher the return an account pays you, there are risks involved, so you may lose money here. In this case, we're just doing a simplified example here, right? But the reality is that the more money you want to make, the more risk you have to take when it comes to investing. All right, so it depends on your risk tolerance level. So if you invest in a conservative account like 5%, then typically you're not going to lose any principal here. All right, so again, keep that in mind. The more money you want to make, the more risk you have to take. Excuse me, when it comes to investing, such as buying stocks, for example, and stocks usually pay a lot higher than 5 and 6%. Okay, so let's look at the formula we have in a table type setup. So let me go and make a big table here, if you would. All right, so make a table with 3 rows in it. All right, and a few columns here as well. All right, so let's put the formula in. So the formula is what? Principal, all right, times the interest rate, say times rate is equal to the interest. Alright, so I is equal to P times R. Again, we're leaving off the T because for the problems on this in this section, T will be 1 year, so we can leave it off. Alright, now what goes in these two boxes? Well, these two boxes are the accounts that we're investing in. We're investing in two accounts. We're investing in the 5% account and a 6% account. So identify those, 5% account and 6% account. Alright? Now, the variable will go into the principal column here. Here's what it says. It says a total of $8,000 is deposited into these two accounts. But of the $8,000, we don't know how much was placed into each account. That's what we're trying to find out. So let's make one of them, let's say X words. Let's make the 5% account X dollars. So I'm putting X dollars of the $8,000 into the 5%. That means how much am I putting into the 6%? Well, that's going to be 8,000 minus X, naturally, because the total is 8,000. Alright? And the rate is, in terms of decimal, is 0.05 here. Alright? Here the rate is 0.06. Alright? So again, so the last column is just what? It's just the product of the first two columns. So principal times rate equals interest. So what's the interest on the 5%? 0.05x. Alright? What is the interest on the 6%? 0.06 times 8,000 minus x. Alright, so that's the interest on the 6%. Again, we'll multiply it out later on. Now it says what? The total interest is what? $450. Alright, so the total interest is $450. Okay, so the total interest is what? Is $450. So how do I go about getting the equation, excuse me, if you will. Alright, so let's look at the interest for 5% account, that's 0.05x. Interest for the 6% account, that's 0.06 times 8,000 minus x. If I add up these two interests here, I'm going to get a total interest of 450. And that's the equation I'm going to come up with here in this problem. Alright, so 0.05x plus 0.06 times 8,000 minus x equal to 450. So that's the equation I need to solve here. Alright? Let's go ahead and solve this equation real quickly. So 0.05x, use your calculator for the decimals here, plus 0.06 times 8,000. So 0.06, use your calculator. 0.06 times 8,000. Hopefully you got $480 here. So 480 times negative x. So minus 0.06x. Alright, just distribute carefully. Again, after I distribute, no more parentheses. Okay? Equal to 450. Alright? Let's go and combine like terms. What is 0.05x minus 0.06x? Well, plug it into the calculator. Punch it in the calculator, excuse me, and you get negative 0.01x plus 480 equal to 450. Alright? So let's subtract 480 on both sides. So not too bad. Take your time on this equation solving here. So negative 0.01x is equal to negative $30. So divide by negative 0.01 on both sides. Alright, so therefore we get x is equal to what? $3,000, right? So let's see, 30 divided by 0.01, just to confirm it. Yep, $3,000. Alright, so that $3,000 goes into which account? That goes into the 5% account, right? So let me say $3,000 for the 5% account. Okay, that's how much we're putting into the 5%. That means we're putting in how much into 6%? Well, 8,000 minus 3,000, so 5,000. So I'm putting in $5,000 in for the into the 6% account. All right, can we see that? So this is our solution: 3,000 to the 5%, 5,000 to the 6% to make $450 in annual interest here. All right. Now, again, how do I go about solving this? I make a table. Okay, so I make a table with the formula principal times rate is equal to interest. All right, what goes in these two boxes? The types of accounts I'm investing in: the 5% account and the 6% account. All right, so here the principal, the total is $8,000, so that's where the variable goes right here in the principal column, but I don't know how much of it will go into this account or that account. So let's make one of them X, the other one must be 8,000 minus X because the total is what? 8,000, that's the key here, all right? The rate is 0.05, 0.06 here. Just convert the rates to what? Decimal. And then multiply to get the interest for each account. In this case, you want the total annual interest to be $450. So therefore, we add up these interests to give us $450, and then we finish solving the equation here. All right. So we get $3,000 for X. Therefore, $3,000 will go into the 5% account, and that means 8,000 minus X goes into the 6%. So 8,000 minus 3,000, which is 5,000 into the 6%. All right. Let's try another one here to give us a better feel for this type of table here. So not too bad at all. Fairly short section. Let me clear this out. Let's look at this problem right here. Alright, so it says an investment of $2,500 is made at an annual simple interest rate of 7%. How much additional money must be invested at 10% so that the total interest earned will be 9% of the total investment? Alright, again, let's take our time to dissect this problem carefully. You try to absorb all the information at once, it can become overwhelming, right? So first thing we're going to do is make our table. Alright, so make our table here. Okay, since I have 2 accounts, I'm going to have 3 rows in it. Let's take your time on that. Alright, so again, put in the formula principal times times rate. Sorry about that, times rate. The time is 1 year, right? So we don't consider that at all for these problems here. Okay, is principal times rate is equal to what? Interest earned. Alright, the interest that we get. Okay, again, what goes in these 2 boxes here? Identify the types of accounts. We're investing in which account? Well, we made $2,500 at 7%, so we have the 7% account here. Okay, so we have the 7%. Put that in. Alright, and then we also have what? It says how much additional money must be invested at 10%. So that's the other account, 10%. So we have the 10% account. All right, so we have the 7% account and a 10% account. All right. Now see what the principal will be. Well, it says what? An investment of $2,500 is made at an annual simple interest rate of 7%. So I'm putting $2,500 in at 7%. So that's not the total like the last problem. So be careful here, right? Read it carefully. You may have to read it more than once. All right. So we're putting in $2,500 here at 7%. All right. Question is, how much additional money do I need at 10%? So that's what I'm trying to find out. How much do I put into a 10%? So let's make that X. All right. So the rate will be what? 0.07 for 10%, 7%, excuse me, and then 0.10 for the 10%. All right. So let's calculate the interest from the 7%. That's just standard 2,500 times 0.07, which is 175. So I get $175 from the 7% account. 10% account is going to be 0.10x. All right. Now it says what? How much additional money must be invested at 10% so that the total interest earned will be 9% of the total investment. All right, so total interest is what? Adding these 2 up again. So that's going to be 175 plus my fault here, plus 0.10x. Sorry about that. So 175 plus 0.10x equal to what? Will be what? 9% of the total investment. So I want it to be equal to 9%, 0.09, excuse me, times, now, if I'm putting $2,500 in here and X dollars in here, then the total investment is what? 2,500 plus X. That's right. So 2,500 plus X is what I want to get at. So again, total interest is 175 plus 0.10x. So this is the 7% interest we're getting. This is the 10% interest money that we're getting. That should be equal to what? 9% of the total investment. This is the total investment here. So up here is the total investment. All right. So let's go ahead and solve this equation now. So that's going to be 175 plus 0.10x equal to, let me distribute 0.09 times 2,500 times 2,500 will be 225. So 225, and then 0.09 times x is going to be 0.09x. All right. Let's go and get x on the left side, numbers on the right side. Let me subtract 0.09 to both sides. 0.09x, that is, minus 0.09x, both sides of the equation. So I get 175 plus, now 0.10 minus 0.09 is going to be 0.01x. equal to 225. And then subtract 175 to both sides. Get the numbers on the right-hand side in this case. Alright, takes care of that. So then I have 0.01x is equal to what? 50 here. So divide both sides by 0.01. So I'm going to get x is equal to what? So I ran out of space here, but divide both sides by 0.01 to solve for x down here. So you get $5,000. Alright, so x will be 5,000. So that's what that means. I need to put in $5,000 into the 10% to get the total interest I make to be 9% of the total investment. So put 5,000 in here to get a 9% return on my investment. Alright, so $5,000 at 9%. Okay, so put $5,000 into the 9% account. That's our solution. Okay, so let's go ahead and look at another one. Let me put out the screen. Alright, let's look at this problem here. A total of $7,000 is invested into two simple interest accounts paying 7.5% and 10% respectively. How much should be invested into each account so that they earn the same interest this time? Alright, so let's make our table here. Alright, so 3 rows in it. Alright, so principal, P, times interest rate, R, is equal to interest. Alright? So let's look at how we go about getting the solution here. Again, what goes in these two boxes? The types of accounts we're investing in. 7.5%, 10%. So we're putting in a 7.5% account and a 10% account. So two accounts we're investing in here. Alright? So it says, well, a total of $7,000 is put into these accounts. But again, of the 7,000, I don't know how much goes into each. So let's make one of them X. For example, let's say I put X dollars into the 7.5% account. That means I'm going to put in what? 7,000 minus X, as you may guess. Since the total, again, is 7. The keywords are word total, 7,000, right? So X dollars in here. That means how much in here? 7,000 minus X, all right? So the rate here is going to be 0.075. And here 0.10 for the 10%. Alright? Let's calculate interest. Again, the last column is just multiplying the first two columns. So 0.075x and then 0.10 times 7,000 minus x. Okay, so again, that's going to be the interest for the 10% account. 0.10 times 7,000 minus x. Alright? So it says what now? Do I add up the interest now? Well, no, I don't, as you can see, right? Because it says how much should be invested into each account so that they earn the same interest. So these two interests will be equal to each other. So don't always think I automatically add these two together. Not always. Maybe usually that's the case on the homework problems, but sometimes it may say same interest. In this case, you have to set them equal to each other. Alright? So the equation we're solving is going to be 0.075x equal to 0.10 times 7,000 minus x. Alright? Let's go and quickly solve this equation then. So 0.075x equal to 0.10 times 7,000 is $700. 0.10 times negative x, negative 0.10x. Alright? Let me get x on the left. So let me add 0.10x to both sides. Excuse me. Alright, so I'm going to get what? 0.175x. This is quite trying to calculate. 0.075 plus 17.5 basically, right? So 0.175x equal to 700. Alright, let's go and divide both sides by 0.175 here. Okay, so therefore x will be equal to, so let's punch in the calculator, 700 divided by 0.175, $4,000. That means what? $4,000 will go into which account? Go into the 7.5% account. So $4,000 into the 7.5% account. All right. And how much into the 10%? Well, 7,000 minus that, so $3,000. So $3,000. $3,000 into the 10% account. All right, so again, $4,000 into the 7.5% account and $3,000 into the 10% account as our solution here. All right, so just practice setting up these problems in this table format. Again, the key idea is what? Principal times rate is equal to interest. Again, the time will always be 1, so we're leaving that off for the problems and on the homework here. And this formula will be sufficient. So practice filling out this table. The variable goes into the principal column, and then we read the problem carefully to get the right equation to solve. In this case, we're not adding the interest. We're going to set them equal to each other because it says they earn the same interest here. Okay, so you can read the problem more than once if you need to, and try to solve them carefully. All right, let's look at percent mixture. If you recall this equation we had last time here, Q is equal to A times R. Remember that? Where Q is what? Q is the quantity of a substance, such as an acid solution, for example, and A is the amount of solution that we're using. All right, and remember R is the what? Is the percent concentration of the substance. Percent concentration of the substance. All right. So again, Q is the quantity of the substance. Amount A is the amount of solution we're using. R is the percent concentration of the substance. So let me give you a quick example of that. For example, suppose in a chemistry lab, I use let's say 200 milliliters of a, let's say, a 70% acid solution. All right, let's say I use 200 milliliters of a 70% acid solution. Okay, so the question is, what is the quantity of acid in that solution? Okay, so in other words, what is the quantity of that substance? In other words, I want to find Q. Well, that's just A times R. So my amount is going to be 200 milliliters. All right, and my percent concentration is 70%. That's going to be 0.70. So therefore, the quantity of acid I actually have in this problem is going to be 200 amount times what? Percent concentration, R, 0.70, all right, which is equal to what? 140. So I actually have 140 milliliters of pure acid, of actual acid, in this solution. Okay, so 70% of it is acid. The rest is what? Distilled water, typically for an acid solution. Okay, but again, get used to this equation of Q equal to A times R. All right, and that's what we'll use in our table setup to solve these percent mixture problems. Let's look at an example of that. Let me go and clear out the screen here. All right, let's go and try this problem. All right, let's look at this problem here. How many ounces of pure water must be added to 75 ounces of a 20% salt solution to make a salt solution that is 15%? So here I'm trying to add water to this 20% to dilute it down to 15%. So I'm trying to reduce the concentration of salt by adding clean, pure water to it. All right? So let's look at the setup here. So let's look at my table here. Make a big table just like we did earlier with 4 rows in it. All right, so let's look at the columns here. Again, this is the amount of solution, all right, times the percent concentration, all right, and that's equal to what? The quantity of substance. Quantity of substance. All right. So again, A times R is equal to Q. Remember from the last screen there. Okay. So again, let's identify the types of materials involved in this problem. There goes that ice cream cart thing in the background. All right. So let's look at pure water. All right. And so I'm mixing pure water with what? 20% salt solution. So 20% salt solution. All right, and I get some kind of a mixture out of that. Okay, so I get some kind of mixture out of that. So I'm mixing pure water with 20% salt solution to get some kind of mixture out of that. That would be 15% salt solution. All right. So let's look at this solution here. So first we're going to fill out one column at a time, if you will, right? So what goes into the amount column? Because how many ounces of pure water? So I don't know how many ounces of water I need to add. Let's make that X then again, all right? It must be added to what? 75 ounces of a 20% salt solution. So I'm using 75 ounces of this guy. So that would be 75. Then the mixture is going to be what? Well, X plus 75, just like the previous example we saw with value mixture. If I use X ounces here, 75 ounces here, then I have X plus 75 ounces in the mixture. Does that make sense? All right. Now, let's look at percent concentration of what? Percent concentration of salt. Now, pure water has no salt in it. Let's observe that. Pure water has no salt. Otherwise, you would die drinking water that has a bunch of salt in it, right? That would be like drinking ocean water, right? And you don't want to do that, obviously. So pure water theoretically has no salt in it. So therefore, the percent concentration of salt, in pure water will be what? 0. Again, pure water has no salt in it, so the percent concentration of salt, we're talking about the percent concentration of what? Of salt here, all right? And there's no salt in pure water theoretically, all right? 20% salt solution, well, 0.2, or 0.20 if you will. The mixture, well, it says to make a salt solution, that is what? 15% salt. So I'm diluting it from 20% down to 15%. It's 0.15, all right? Again, the last column is just what? The product of the first two columns. So X amount of water times no concentration of salt, so there are actually 0 salt, 0 quantity of salt. All right, 0, that's a B right there, substance, right? So 0 quantity of salt in pure water, so 0, big fat 0 here, all right? How about 75 times 0.2, punch on the calculator, 75 times 0.2, so I get 15. So this is 15, there's actually 15 ounces in the 75, right? Because 20% of it is what? Actual salt. So it's, again, the last column is what? Product of the first two columns. So 75 times 0.2, 15. And here, down here, 0.15 times X plus 75. All right? Again, the quantity of the mixture, the quantity of substance in the mixture is the total quantity. So that means what? That means we get out of it what we put into it. So therefore, it's going to be 0 for the quantity of, from the pure water, 0 salt there, plus 15 ounces of salt from the 20% salt solution. That should equal to the quantity in the mixture, 0.15 times X plus 75. Okay, let's make sure we see that again. We get out of it what we put into it. Okay, bottom line. So that 0 plus 15 is obviously 15, equal to 0.15x. All right, and 15 times 75, so 0.15, excuse me, times 75 is 11.25. All right, let's go and subtract 11.25 on both sides of the equation to get it onto the left-hand side here, since I have the x term on the right-hand side. All right, so 15 minus 11.25 is what? 3.75, I believe, equal to 0.15x. Dividing both sides by 0.15. Oops, that's a 5 there. Sorry about that. Divide both sides by 0.15. Cancels that out. Sorry about that. And so 3.75 divided by 0.15 is going to be what? Oops, 3.75 divided by 0.15 on the calculator. So x will be equal to 25. 25 ounces of what? Pure water we need to add. So if I add 25 ounces of pure water into 75 ounces of the 20% salt solution, it will dilute the solution down to 15%. So the answer here is 25 ounces of pure water. Again, we're using this table here of A times R, amount of solution, times percent concentration of solution, is equal to the quantity of substance in the solution. All right? So let's go ahead and try another one. Let me clear out the screen. The key idea for the equation is what we get out of it, what we put into it. Okay, so let's go and try this one. All right, let's look at this example here. A silversmith makes 60 grams of one alloy that is 50% silver with 200 grams of another alloy that is 69.5% silver. Find the percent of silver in the mixture. So I want to know the percent concentration of silver in the mixture now. All right, so let's go and make a table once again. So let's identify the types of material that we're mixing here. All right, so let's make 4 rows here. Take our time on that. All right, so let's go ahead and look at the amount here. So I'm mixing what? The material here that I'm using here. So let's look at the amount of solution times the percent concentration. That's a C there, percent concentration. You could say A times R for percent concentration is equal to Q, quantity of substance. So quantity equal to quantity of substance. All right. So let's identify the materials involved in this problem. So we're using a 50% silver. So we're using a 50% silver alloy mixed with a 69.5% silver alloy. So 69.5% silver. So I'm mixing 50% silver alloy with 69.5% silver alloy to get some kind of a mixture out of it. All right. So let's look at the amounts. Well, I'm using 60 grams of the 50%. So I'm using 60 grams here. 6. All right. I'm using what? 200 grams of the 69.5%. So 200. So if I use 60 here and 200 here, it's going to be what? 260 in the mixture. All right. So let's look at percent concentration. Well, 50%, so 0.5% concentration of what? Silver in this case. The mixture, 0.695 or 69.5%. And for the mixture percent concentration, well, it says what? Find the percent of silver in the mixture. That's what we're trying to find out. So we don't know this. So that will be X. But again, keep in mind that our concentration of silver should be between 50% and what? 69.5%, since I'm using these two materials to form this mixture. So the concentration of the silver in the mixture should be between 50% and 69.5%. Keep that in mind. All right? So let's go and work it out. So what is 60 times 0.5? So that will be what? That will be a 30. Okay, 30 grams of actual silver, the quantity of silver in this case, right? 30 grams here in the 50%. How about 200 times 0.695? So let's write down 200 times 0.695 in the calculator. That'll be 139 on the calculator. All right, and 260 times x. Again, the last column is a product of the previous two columns. That'll be 260x. All right. Again, that's the total quantity of silver here. We get out of it what we put into it. So therefore, 30 plus 139 is equal to 260x. All right, so let's add them up to here. 30 plus 139 is 169, equal to 260x. Dividing both sides by 260. We get our result here of what? Let's see, let's punch that into the calculator here. 169 divided by 260, excuse me. All right, 0.65. We get 0.65. So the resulting mixture is going to have a concentration of silver of 65% silver for the mixture. All right, so that's what we get, 65% silver for a mixture. So we get 65% silver for the silver concentration in the mixture here, which makes sense because, again, I mentioned this number here should be between 50 and 69.5%, and we got 65%, which is between those two numbers. Now, since we're using more of the high concentration of silver and less of the low concentration of silver, therefore my answer X should be closer to the high concentration, and which it is. 65% is closer to 69.5% than 50%, as you can see here. So this answer does make sense here. All right, so practice setting up these problems using this table format here. A times R is equal to Q. Again, amount of solution times percent concentration equal to the quantity of substance, All right, in this case, the quantity of what? Silver in this problem. All right, let me use some problems to solve and post the answers to on Blackboard in the discussion area. Okay, again, sorry for the interruption there, but that's right. So let me go ahead and give you a couple of problems to solve and post answers to in Blackboard here. Post the answers in the discussion area. So let me go and clear out this screen here. All right, let's take a look at the Blackboard problems for this section. All right, so number one, an investment club invested part of $14,000 in a 4.5% simple interest account and the remainder in a 7.5% simple interest account. The total interest earned was $900. How much was invested into each account? All right, so investment problem. Number two, also investment problem. Steve made a deposit into a 7% annual simple interest account. He also made another deposit, $1,500 less than the first, in a 9% simple interest account. So the second account should be $1,500 less than the first. Keep that in mind in terms of the principal column. All right. The total interest earned on both investments was $505. How much was deposited into each account? All right. And number three, the percent mixture problem. Take a look at that. A chemist has some 12% salt solution and some 9% salt solution. How many milliliters of each should be mixed to make a 450 milliliter solution that is 10% salt? All right, so we're mixing 12 and 9 to get 10% out of that. All right, so you can figure out what we need in that situation. All right, so we'll go over in class. Take care, and until next time.